Okay, 8-4 is some application questions looking at things called angles of elevation and angles of depression. Looking forward horizontal, if you look up, it's an angle of elevation. If you have to look down, it's an angle of depression. Okay, elevation, depression. Okay, so in this picture, angle 1, the submarine would be looking up from its horizontal. This would be an angle of elevation. Okay, the boat, at angle 2, would be looking from horizontal, be looking down. It'd be an angle of depression. Okay, angle 3, from the horizontal to looking up, so it's an angle of elevation. And 4, the tree would be looking from horizontal, be looking down, so it'd be an angle of depression. Okay, I hope that makes sense. Just looking at this one, angles 7 and 8 would be angles of depression. Angles 5 and 6 would be angles of elevation, looking up or looking down. Okay, so number 10 is very similar to the problems we did in 8-3. So I'm going to skip that one. This one looks a little different because the angle's in a weird spot. But if you consider the fact that the dotted line is horizontal and this line is also horizontal, that must mean that this angle and this angle are alternate interior angles. Okay, and so this must also be 18 degrees. So I can use that to find x, just like I did before. I'll use a trig ratio, so katoa. I know the adjacent, I want to find the opposite. So the ratio that relates opposites and adjacents is the tangent. So the tangent of 18 degrees is equal to the opposite over the adjacent. Okay, make it into proportion, cross multiply, x times 1 is x. 2 times the tangent of 18 is 2 tan 18. So I grab my calculator, 2 tan 18 is 0.65. Okay, so the length of that, the height of this triangle is 0.65. Okay, a couple of word problems. A meteorologist measures the angles of elevation of a weather balloon as 41 degrees. A radio signal from the balloon indicates that it is 1,503 meters from his location. To the nearest meter, how high above the ground is the balloon? Okay, so the meteorologist is down here, okay, looking up to see a balloon. Horizontal, looking up. Okay, 41 degrees. Make it a right triangle. A signal from the balloon indicates that it is 1,503 meters from his location. That would be the hypotenuse is 1,503. Okay, to the nearest meter, how high above the ground is the balloon? Now again, I think we'll just kind of throw out how tall the meteorologist is, because it's maybe 2 meters or so. Okay, so looking at this, I'll use a trig ratio, so katoa. And let's see here. I know the hypotenuse, I want to find the opposite. So opposite and hypotenuse is the sine ratio. So the sine of 41 degrees is equal to the opposite over the hypotenuse. Make it a proportion, I cross multiply. X equals 1,503 times the sine of 41. 1,503 sine of 41. X is equal to 986 meters. So from the meteorologist's eyes, it's 986 meters above that. Okay, last example, flagpole. The world's tallest unsupported flagpole is a 282 feet tall steel pole in Surrey, British Columbia. The shortest shadow cast by the pole during the year is 137 feet long. To the nearest degree, what is the angle of elevation of the sun when casting the flagpole's shortest shadow? Okay, so I have a flagpole. I'll just draw the pole, not the flag. and the flagpole is 282 feet. Okay, the shadow, draw that on the ground, the shadow is 137 feet long. And the question is, what is the angle of elevation to the sun? So from horizontal, looking up at the sun, what is this angle, the angle of elevation? Okay, so I'll use here, so, ka, toa. Let's see here, I know the opposite and the adjacent. And the opposite and the adjacent are the tangent ratio. So the measure of angle A, I'll call it, is equal to the inverse tangent, because I know the ratio, and the tangent ratio is the opposite, 282, divided by the adjacent, 137. So the inverse tangent of 282 over 37 is 64 degrees approximately. So that angle of elevation must be 64 degrees.